Question 6.5. The enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are given here. So enthalpy of combustion of methane is minus 890.3 kilojoule per mole. Enthalpy of combustion of graphite is minus 393.5 kilojoule per mole, and last one, enthalpy of combustion of dihydrogen is minus 285.8 kilojoule per mole. Find enthalpy of formation of CH4. Okay, so here we have to find out enthalpy of formation of CH4. So to find enthalpy of formation of CH4. So what is meaning of enthalpy of formation, which is given here in this definition? The standard enthalpy change for the formation of 1 mole of compound from its elements in their most stable states of aggregation is called as standard molar enthalpy of formation. So in this case, enthalpy of formation of CH4 means 1 mole of CH4 is formed using its element in their most stable state. So we know that CH4 will form from carbon, which is in solid state, plus hydrogen, which is in gaseous state, to form CH4, which is in gaseous state, and here we are forming CH4, hence we are forming 1 mole of CH4. To balance this chemical equation, I am taking 2H2. For this reaction, we have to find out enthalpy change of formation, which is given as delta FH. This is required quantity. Then let's write down given quantity. In this question, enthalpy of combustion of three compounds are given. So what is meaning of enthalpy of combustion, which is given in this definition? The enthalpy of combustion of substance is defined as the heat change when 1 mole of substance is completely burned in presence of oxygen. So in this case, combustion of methane means 1 mole of methane is completely burned in presence of oxygen. So let's write down first reaction. We know that methane is in gaseous state, and when it burns in presence of oxygen, it will give CO2 plus H2. We know that all organic compound will give CO2 plus H2O on combustion. So here this O2 is in gaseous state, CO2 also in gaseous state, and H2O is in liquid state. Let's balance this chemical equation. So here H4 is balanced by writing 2 here, and after that this O2 is 2 oxygen and 2 oxygen is 4 oxygen will balance by writing 2 here. And here change in enthalpy delta H of combustion is given as delta C of H is equal to minus 890.3 kilojoule per mole. Okay, so let's observe the given quantity and required quantity. In this case, the CH4 is on left hand side, that is on reactant side, and in required equation, CH4 is on product side. So we have to change the given equation according to required equation. So for that, I am reversing equation 1. So reversing equation 1. So reversing equation means I am writing product on reactant side and reactant on product side. So equation 1 now comes out to be like this. Okay, as I reverse this equation, the sign for delta H will reverse and it will become plus 890.3 kilojoule per mole. Okay, so this step is very important. I am writing this newly formed equation as equation 1 in Roman. Then second equation is enthalpy of combustion of graphite. So graphite is nothing but carbon in solid state. So carbon reacts with oxygen, that is burn in presence of oxygen to give CO2, which is again in gaseous state. Okay, this is combustion of graphite. So this reaction is balanced and here delta H, see here I am writing delta H1, here I am writing delta H2 is equal to minus 393.5 kilojoule per mole. Okay. Then third reaction, that is combustion of dihydrogen. Dihydrogen means H2 plus, every time write down its state, H2 in gaseous state plus O2 in gaseous state gives H2O in liquid state. While balancing this chemical equation, remember that in enthalpy of combustion, we burn the reactant which is of 1 mole of substance. So keep this H2 as 1 mole. So to balance this I am writing half O2. In this case, change in enthalpy, that is delta H3 is equal to minus 285.8 kilojoule per mole. Correct? See his third equation and required equation. So in required equation we need 2 moles of H2. So I need to change this equation 3. So I am going to multiply equation 3 by 2. So 2H2 plus half into 2. If I multiply half into 2, it will become 1. So 2H2 in gaseous state plus O2 in gaseous state gives 2H2O, which is in liquid state. And this newly formed delta H is equal to 2 into minus 285.8. Okay, if I multiply this quantity, then I will get delta H, that is change in enthalpy, is equal to 571.6 kilojoule per mole. Correct. So consider the second equation as equation number 2 and this third equation as equation number 3. So I am going to add all these three equations, equation 1, 2 and 3. Adding equations 1, 2 and 3. So first equation is CO2 plus 2H2 gives CH4 plus 2O2. So I am writing that equation here. CO2 plus 2H2O gives CH4 plus 2O2. Then second equation is C plus O2 gives CO2. C plus O2 gives CO2, and third equation is 2H2 plus O2 gives 2H2. Okay, so let's do addition for these three equations. Okay, so while adding this, the same terms on left hand side and right hand side will get cancelled. So here CO2 will get cancelled. Then this one O2 plus this one O2 will be 2O2 will get cancelled with this 2O2. Then 2H2 will get cancelled with 2H2. And finally, remaining quantities are CH solid plus this 2H2 in gaseous state gives CH4 in gaseous state. Okay, equation is our required equation. Okay, C plus 2H2 gives CH4. Okay, so in this case, change in enthalpy delta H is nothing but addition of all these three terms, delta H1 plus delta H2 plus delta H3. So what is value of delta H1? Delta H1 is 890.3 kilojoule per mole. Then delta H2 is minus 393.5 kilojoule per mole. And delta H3 is equal to minus 571.6 kilojoule per mole. So I am writing here 893.3 minus, because delta H2 is negative, 393.5 minus 571.6. After doing this addition and subtraction, I will got answer as minus 74.8 kilojoule per. Okay, and this is nothing but delta H, which, which is enthalpy change of formation of CH4 for this required equation. Okay, therefore final answer would be enthalpy of formation of CH4 is minus 74.8 kilojoule per mole. Thank you.